Okay, folks, looking at some AS maths, okay, looking at coordinate geometry, specifically straight line graphs and straight line equations. It says the line L, so little l, passes through the points A, which is 1, 4, and B, which is minus 2, 13. Part A, find an equation for L. So for an equation of a straight line, guys, we need two things. We need a gradient and we need a y-intercept. Okay, so we want it in the form or format y is equal to mx plus c, where m is our gradient function, okay, so how steep the line is, okay, the coefficient of x, the number next to the x, and c is our y-intercept, where it crosses on the axis, so y-axis intercept. Okay, I mean, if you want to, guys, here, you're obviously welcome to draw like a little drawing here, just to have like an idea of what it would look like. Okay, there is no harm in doing that. So 1, 4, probably somewhere there, and then minus 2, 13, probably somewhere there. Okay, so we've got like a straight line there. Okay, and this will be important, especially here for part B, which I'll go into more detail here when we look at part B. Okay, but this drawing here will come in extra handy for part B. Okay, but that is a rough sketch of what points A and B would look like. So, to work out the gradient is the change in y over the change in x. So delta y over delta x. So change in y over the change in x. So the difference in the y coordinates divided by the difference in the x coordinates. So we're going to do 13 minus 4 over minus 2 minus 1. 13 minus 4, guys, is 9 over minus 2 minus 1 is minus 3. So be careful there with the negatives. And 9 over minus 3, so 9 divided by minus 3 is minus 3. So m is equal to minus 3. So straight away, our answer is going to be in the format y is equal to minus 3x plus c, or negative 3x plus c. I can now substitute either one of the coordinates a or b to work out value for c. Again, it doesn't matter. Okay, I'm going to go for a, okay, because it's just a bit easier. So we have y is 4 when x is 1. So 4 is equal to minus 3 times 1. So minus 3 lots of 1 plus c. Minus 3 times 1 is minus 3. So we have 4 is equal to minus 3 plus c. Adding 3 to both sides, so plus 3 and plus 3. 4 plus 3, 4 add 3 is 7, so 7 is equal to c. Therefore, c is equal to 7. So piecing my answer or answers together, the equation of line L is y is equal to minus 3x plus 7. Now, just actually clarify here for this particular question here, it doesn't specify here to give it in this format, but we usually give here equations of straight lines usually in the form or format y is equal to mx plus c, but depending on what exam board you have, okay, it might be here in like a different format. So it might be here ax plus by is equal to c, or ax plus by plus c equals 0. Okay, depending on obviously what exam board you are. Okay, so I know that, yeah, obviously OCR, okay, yeah, or OCR A examples usually, yeah, like to have it in this format. Okay, but again, it's not specified. But as long as, yeah, like if I rearrange it and get back to this, then either applicable formula answer is fine for the examiner. But bear in mind, yeah, depending on what exam board you'll be doing in September or next year or the year after, okay, whenever you watch this video, okay, we usually leave our answer or answers in the form y is equal to mx plus c unless otherwise told. Part B says find the exact length of AB. Now, when we're looking at lengths of 2 points, okay, we're actually going to be using a triangle, okay, specifically a right angle triangle. And because it's right angled, we'll be using Pythagoras' theorem. Okay, here you're going to be a bit more careful, okay, when we work it out. Okay, so because he wants the exact length here, we are going to leave our answer as a third or a square root. Okay, so it's going to be the square root of, okay, I'm going to work out the difference in my x coordinates, okay, square it, and then difference in the y coordinates. So for x, we're going from 1 to minus 2, so that'll be 3 squared here or minus 3 squared, okay? It doesn't actually matter here about the sign here, because obviously if I square it negative, I get a positive. If I put a 3 there, that is also fine. And then from 4 to 13, we're going up by 9, okay? So 3 squared makes 9, 9 squared makes 81. So you have the square root of 9 plus 81, and 9 add 81 is 90. So we have the square root of 90, okay, which if I want to, okay, I don't have to, I can simplify this third. Okay, so root 90, or the square root of 90 can be written as root 9 multiplied by root 10, okay, and the square root of 9 here is just equal to a whole number is equal to 3, so we have 3 times root 10, which is 3 lots of root 10. So the length of AB in exact form is root 90, or 3 root 10, or 3 lots of root 10. Okay, so remember that is obviously working with Pythagoras. Okay, so yeah, you're doing the square root of x minus x1 in brackets all squared plus y in brackets y minus y1, okay, or y2 minus y1, yeah, all squared, okay, and then you're obviously square rooting that. Okay, so you're finding, yeah, the difference in the x coordinates, you square that, plus the difference in the y coordinates, and obviously you square that, and then you're doing the square root of the sum of that, okay, using Pythagoras. Okay, again, very important topic, will come in handy for A-level maths and even A-level further maths. Okay, but hopefully that makes sense. But this topic here is looking at coordinate geometry, specifically, okay, straight line graphs, okay, in the AS pure maths section. Okay, the first part, yeah, I'd say is obviously GCSE material, okay, but we are now in AS maths, so we can use our calculators, okay, for these sort of questions. But yeah, bear in mind that if you want to answer in exact form, it's usually as a third, or in terms of pi, or as a fraction. Okay, so bear that in mind, okay, for your exam. But yeah, obviously in AS maths, we are allowed to use our calculators, okay, to help us with the mental maths part of these questions, so bear that in mind.